All right, we're going to look at another conic. So you've looked at circles, ellipses, hyperbolas, and now it's time to look at a parabola. And what do we have here? We have y squared equals a times x. And we're going to do a couple of different examples just so that you know that this is a graph. And so it doesn't always have to be a function. This time we're just going to draw a sketch or a set of ordered pairs. And those ordered pairs doesn't always have to be a function when we're talking about conics, right? An ellipse is not a function. A circle is not a function. A hyperbola is not a function. And the parabola is also not always a function. It just depends on which way it's oriented. Let's write the general form of a parabola using the definition. The definition would say y minus k quantity squared is equal to some a times x minus h. And if a is positive, it opens to the right. If a is negative, it opens to the left. In this case, what do we have here? We have y minus 0 quantity squared is equal to negative 2 times x minus 0. So the vertex, remember the vertex is h comma k. So here the vertex is 0, 0, not a total surprise. We could go ahead and plot that. And then we know it's going to open to the left. We're going to open to the left here. So it would be nice to pick at least 3 to 5 ordered pairs. So why don't you pick x to be 1? Or you should say, how about we do it the other way? Why don't we pick y to be 1? If you choose y to be 1, that implies that x is negative 1/2. And if you choose y to be negative 1, we get the same value, right? So we get, so we get we have an ordered pair here and here. If you don't like that, we could write what? Negative 1/2 and 1, and then negative 1/2 and negative 1. This tells you that this is not a function because this has 2 y's for a single x, and this breaks the rule of a function. So here we're just drawing a graph. We're drawing a set of ordered pairs in the Cartesian plane. You might want to pick y to be 2. That might be a better way to get some decent ordered pairs. If y is equal to 2, we get x to be negative 2. And if y is equal to negative 2, we get negative 2 squared equals to negative 2 times x. You still get x to be negative 2. So once again, you get ordered pairs, negative 2, comma what? Comma 2, and then negative 2, comma negative 2. Get a parabola here. There we go. And then play connect the dots. Opens to the left. Make sure you draw this on your own paper. Use your graph paper if you have it ready. If not, just be neat and label everything. You can certainly put all of the ordered pairs in a T-chart as well. Negative 1/2, 1, negative 1/2, negative 1, negative 2, 2, negative 2, negative 2. That would help you. How about this one? This time I'll make the T-chart first. How about that? Let's write it in one of its standard forms. This standard form is a little different. This is x minus h quantity squared is equal to a times y minus k quantity squared. I shouldn't call this standard form, but this is more related to the form called the definition of a parabola. It's equal to negative 2 y minus 0. So the vertex is once again 0, 0. But this is not going to open left or right. Do any of you know which way this is going to open? You can always pick ordered pairs here. Why don't we pick x to be -3? So if you pick x to be -3, we get -3 squared is equal to -2y. So y is equal to what? 9 over -2, which is -4 1/2. And if you pick x to be 3, we still get what? 9 over -2. So when x is 3, we get 4 1/2, -4 1/2, right about here. And x is -3, we get -4 1/2. So we get it here, play connect the dots, bam. We have a parabola that has a maximum. The maximum y value is 0. Yeah. So this one happens to be a function. This passes the vertical line test and the rule that says for every x, there's exactly one y. Over here, this one is not a function. This is not a function. So make note of that. Oh, we graph both parabolas. Oh, I need a t-chart here, 0, 0. Should put the most important ordered pair. You gotta have the most important ordered pair in your t-chart if you're going to go with a t-chart organization. Let's circle our graphs and circle our labels. That's what we need. Let's circle our labels. Let's circle our graph, our labels. Yeah, and it's good to know that this is not a function and this one is a function.